Hi and hello to everyone. In this video, we are going to look into the convolution in discrete time domain. We will be using three techniques to do the convolution in discrete time domain. That is, straight away using the expression for convolution, and we'll be using moving train and platform approach. Also, it is also called graphical approach. We will use that technique also. The third technique is the easiest of the three techniques, that is the tabulation technique or tabulation method. We'll be using all the three techniques to do convolution in discrete time domain. Welcome to the lecture. First thing, we have to understand what is convolution, right? Before convolution, in the last video, I have explained about the impulse response. Those who have not watched the video, there will be a link appearing at the top right hand side. You please watch that video. Quickly refresh what is impulse response. If you take a system, let me say the system is, this is my system, right? It's a discrete time system. I make it as DTS, discrete time system. I give the input as impulse, delta of n or delta of t. The output I am getting is h of n. I explained already how to find the impulse response in the previous video. This is just a quick refreshment. Okay, so this is called impulse response. I give the input as impulse, the output is called impulse response. Why this impulse response is very important, right? See, in discrete time domain, I will be using impulse response as h of n. In continuous time domain, I will be using impulse response as h of t. That is the difference, right? Okay. Now, why this impulse response is important? Because if the impulse response is known, that is, the h of t, impulse response is h of t or h of n is known for the system, then output. What is the output? Output is y of t or y of n. Okay, generally that's how we give the name the output, right? Okay, in continuous time domain it is y of t, in discrete time domain it is y of n. Can be obtained for any input. Input can be x of t or x of n using convolution. Okay, so the thing is, if you know the impulse response, you can find the output for any input by using what method? Convolution operation or convolution method. That is why we are very much interested in finding the impulse response. Once we know the impulse response, we can easily find out the output for any input. Okay, right. Now this is the expression for convolution in continuous time domain. This is the expression for convolution in discrete time domain, right? Before doing convolution, definitely we should have the impulse response, that is your h of t or h of n. In continuous time domain, this is in discrete time domain. In continuous time domain, this is the convolution operation. In discrete time domain, this is the convolution operation. Note that in continuous time domain, we will be using integration. In discrete time domain, integration, instead of integration, we will use the symbol summation, because discrete can be only summed up. We cannot integrate, right? Fine. Now, remember that convolution in discrete time domain is very easier mathematically to solve when compared with the convolution in continuous time domain. That is why in this lecture we are going to deal only with discrete time convolution or convolution in discrete time domain. The next video or the next lecture I will be helping you in convolution in continuous time domain. Okay. Now observe the expression. What I am doing is I have the input x of t or x of tau and the impulse h of t. Here I am at t minus tau. I am multiplying it, then integrating it. Okay. This is how the convolution in continuous time domain is done. Now observe the convolution in discrete time domain. Okay, I have the input is x, impulse is h. I am multiplying those two, then I am summing up. Thereby I will get the output y of n. Okay, let us start with the first technique. Before going into that, we look at some properties, right? This is again I have written the same expressions, right? Now remember that convolution is indicated indicated by notation or mathematically by the star symbol, this into mark, okay, asterisk. This is the convolution, symbol of convolution is star. Convolution I will indicate by the star or asterisk notation. Okay. The first property is convolution operation is commutative. What is the meaning of commutative? See, I have the input, I have the impulse. I can convolve it like this, or x of t convolved with h of t is equal to h of t convolved with, say this star symbol as convolved. This is in this, we have to pronounce this as convolved or convolution operation, convolved. H of t convolved with x of t. Similarly, in discrete time domain, x of n convolved with h of n is equal to h of n convolved with x of n. There is nothing wrong in changing x and h position. Okay, here what we have done, we have taken the x and we are moving h. Here we have taken x is x, and what we are shifting? We are shifting the impulse response. Look at here, the commutative property, what I am doing, I am keeping h as stationary. Remember, here x is not moving. Here h is not moving. Here impulse is shifted, t minus tau. Here input is shifted. Both are correct. This is this and this. You can use any of the expression to find out the convolution. Similarly, in discrete time domain, you can use any of this expression, right? Here x is not moving, x of k is stationary. Here h of k is stationary. Here what is shifted? Impulse is shifted. Here input is shifted. Okay, so you can use this expression or this expression, or else in continuous time domain you can use this expression or this expression. Both are correct. The meaning is convolution operation is commutative. Okay, you can either convolve x with h or h with x. Both are same. We look at some other properties. Yes, this is very important property. Associative property. Assume I have the impulse response indicated by, I have two systems whose impulse response is h1 and h2, right? So let us take a system like two systems are there whose impulse response is h1 of t and h2 of t. They are in cascade. This operation, sorry, this we say in cascade. Okay, right. So what I'm doing is I'm giving the input x, I'm getting the output y, right? So if you ask me what is y is nothing but input convolved with h1 and the result is convolved with h2. You see, x of t input is convolved with h1 and the answer is convolved with h2. Okay, in by associative property, what I can do is I can convolve h1 and h2. This two I can convolve first. This two I can convolve first, and then I can convolve with the input. Both are same. Okay, order is not important. I can do x with h1, then the result I can convolve with h2, or else I can convolve h1 and h2 and I can convolve the result with x. Similarly, in discrete time domain, instead of t I am putting n, both are same, right? This is in cascade. Associative property I can apply in cascade. Then what about distributive property? The distributive property is used for parallel systems. If two systems are parallel, that is, this is my h1 of t, this is my h2 of t. Okay, I am adding. Here, this is my input x of t. Output is y of t. Right? So, what can I do? If they are in parallel, h1, h2 are parallel. I can add these two. I can make this as h1 plus h2. Then I can convolve with x of t. That's what I done here. h1 plus h2 convolved with x of t. Remember, these are two systems. This is for the system 1, the impulse response h1 of t. For the system 2, the impulse response is h2 of t. I can add those two impulse responses, then I can convolve with x, thereby I will get the output. Instead of that, I can multiply x1 with, I can convolve x1 with h1. I can process this separately. Then I can process x1 with h2, convolve it. Then I can add. Okay, this property is called distributive property. Okay, these are the important properties of convolution operation. Okay, because see what is the signal available at this point. Here I can get it as x of t convolved with h2 of t. What here it is x of t convolved with h1 of t. Okay, I can do it like individually x convolved with h1, x convolved with h2. Then I can add, or else add the impulse response h1 plus h2, h1 plus h2. Then you convolve with x of t. Okay, so this is applicable for even for discrete time domain. No time explaining only for continuous time domain. Just you can replace t with n. The same property is applicable for discrete time domain. Okay, let's take a problem. Problem gives a very good idea. We take an example, then we will understand how to do convolution. As I explained earlier, we are very much interested in doing convolution in discrete time domain because it is very easier when compared with continuous time domain. Continuous time domain convolution I will be explaining in the next lecture or next video. Okay, here the input I am taking, that's why x of n I am taking as 2, minus 3, 6 and 1. Okay, h of n, that's the impulse response, that's 1, 3 and minus 2. What does this arrow indicates? This arrow indicates this is the n equal to 0. So this point, so let me change this color. Yeah, so this is x of 0. This is x of minus 1. This is x of 1. This is x of 2. Similarly, this is x of 0. This is x of 1. This is x of minus 1. Okay, this is how this arrow used to say that this point is n equal to 0. Fine. Now the question is find the output. And we know this is the convolution in discrete time domain expression. Okay, this let's see, this I will be these steps to be followed for convolution. I will be using for the second technique, that is your train and platform approach or graphical approach. Okay, for expression, now we are going to see only the expression, so we will be using this straight away. We'll be solving the problem using the first technique. For the second technique, I will be explaining this. Let's wait for a moment. Okay, fine. So this is the question. Okay, right. So the thing is, we know this is your x of minus 1, x of 0, x of 1, this is x of 2. Similarly, this is your x of minus 1, this is your x of 0, this is your x of 1. Okay, right. Now, so this is your convolution expression. I have the input, I have the impulse response, I have to find the output y of n. Output y of n. Right. Now we have to find what is the range of the output y of n. Okay. Right. Before that, we have to see what is the range of the input, what is the range of the impulse response. We can see the range, it is from minus 1 to 2. The range is from minus 1 to 2. Similarly, for the impulse response, the range is from minus 1 to 1. So this is from negative number minus 1 to negative time positive time plus 2. Here from negative time minus 1 to positive time 1. This is the range of the input and impulse response. Okay. Now to find the range of the output, to find the range of the, what I am doing is I am adding the negative range of input and negative range of impulse response. What is the negative range of input? Minus 1. What is the negative range of the impulse response? Minus 1. Okay, so minus 1, it is minus 2. Right, I'm making it as n1, this is n3, so n1 plus n3. What is the positive range, maximum positive range? It is from minus 1, 0, 1 and 2. So n2 is 2. Similarly, this is 0 means this is 1. Okay, so positive range is n2 plus n4, maximum of positive range in input and impulse response. So 2 plus 1, it is 3. So n ranges from minus 2 to minus 3. So this n is going to be from minus 2 to minus 3. So what we have to find? We have to find outputs of y of minus 2, y of minus 1, y of 0, then y of 1, y of 2, y of 3. We have to find these outputs. Okay, right. Now, first I am taking is y of minus 2. N ranges from minus 2 to 3. I am putting n value minus 2. So here I put n value minus 2. So I have to put various values of k. What is the k value? It is from minus infinite to plus infinite, right? So we cannot put a minus infinite very high values to some positive very high values. We had a very lengthy expression. But this input and output is only for what is the range of input? X of minus 1, x of 0, x of 1, x of 2. Similarly, the impulse response is x of minus 1, x of 0 and x of 1. Okay, it is only finite range. So by trial and error, or else I can say by observation, what technique I follow is I will look at the range in magnitude, right? What is the maximum magnitude of the number? It is 2. What is the minimum magnitude of the number? It is minus 1. See, I will take the maximum and minimum range, right? It is 2 here. If you compare this minus 1, see, plus 1, 2, which is maximum 2. So I will take it as 2. Okay. Then what is the minimum number? Minimum number is minus 1. Take the magnitude. Magnitude minus 1, magnitude is here also minus 1, here also minus 1. So the magnitude is 1. So 2 plus 1, 3. 3. So I will take the k range from, instead of minus infinite, I will put minus 3 to plus 3. This is the technique I follow. This is very, see, better. Instead of going for trial and error method, this is the maximum range where you can get some values. Beyond that, less than minus 3 or greater than 3, will definitely get the answer as 0. Okay, so how I got this 3, I'll explain again. We look at the maximum range, right? In the positive, it is 2 here. In the positive, here it is 1, which is maximum 2. I will put 2. The negative, what is the maximum? Minus 1, here it is maximum. Maximum is minus 1. Okay, so what is the magnitude of minus 1? 1. So 2 plus 1, 3. So I will take 3 as the limit. So in negative side I put minus 3, positive I will put plus 3. Now just plugging. Okay, you have to put the values of minus 3, minus 2, minus 1, 0, 1, 2, 3 in this expression. That's what I have done here. First I am putting minus 3, x of minus 3. In place of k I am putting minus 3. So minus of minus 3. Multiplication is over. Plus, because of summation symbol I am putting plus. Then I am putting minus 2. Okay, first I put minus 3, then I am putting minus 2. So in place of k I am putting minus 2. Then plus I am putting minus 1. Then I am putting 0. Then plus 1. Then plus 2. Then plus 3. Okay. Right. Now on solving, we get these things, right? Do you know what is x of minus 3? Because x of minus 1 is 2, minus 2 and minus 3, there are no values, it is 0. What is h of 1? So remember, sorry, beg your pardon. This should be h. This is h of minus 1. This is h of 0. This is h of 1. Okay. Right. So what is h of 1? H of 1 is minus 2. Then what is x of minus 2? X of minus 2 is not there, so it is 0. What is h of 0? It is 3. What is x of minus 1? X of minus 1 is 2. What is h of minus 1? It is 1. Similarly, what is x of 0? X of 0 is 3. X of 0 is 3. Then what is h of minus 2? H of minus 2 is not there, so it is 0. Likewise, you can put the values. Okay. So on multiplication, we get y of minus 2 as 2. Okay. Next, let me try with for n equal to minus 1. N equal to minus 1. In the convolution expression, I am putting n equal to minus 1. So put various values of k from minus 3 to plus 3. Just you have to plug the values of k. Put the values of k as first what? Minus 3. Then you put minus 1. Then you put minus, this means 0. First you put minus 3 in the values of k. Then you put minus 2. Then you put minus 1. Then you put 0. Then 1, 2, 3. These values of k you put in. Okay. And you sum everything. And you put the value finally from the question, substitute those values. Okay, you add that, you'll get the answer as 3. Try for y n equal to 0. N equal to 0 means what happens? N minus k. So n is 0 means minus k. Okay, these things you can pause the video and you can note down the steps, right? You get the answer as minus 7. Okay, I have left out n equal to 1, n equal to 2, n equal to 3 for your own practice, right? On solving, you will be getting the answer as y of 1 as 25, y of 2 as minus 9, y of 3 as minus 2. This is how we can do convolution in discrete time domain using the expression. Now we go to the second approach. That is the moving train and platform approach. Okay. So what I'm doing is, before going to that, I will show the, yes, this is very important. Okay, note down these steps. These are the steps we follow. See, this is the expression we have. How to solve this expression is explained in these steps. What is the first step? Is we have to rename. Instead of n, we have to replace with k. X of n, we are giving the name x of k. Similarly, h of n, we are giving the name h of k. This is the first step. Okay, take the question. X of n is given means you replace x of n with x of k. Everything will be the same. Instead of n, we will be using k. Similarly, h of n, we will make it as h of k. Okay, fine. Now, if you observe this expression, which is constant, n is constant, right? N can be, as we worked out, n can be, if you put n as 1, only k is changing. Similarly, n as 2 means only k is changing. Okay, so I have explained already. If there is a shifting and time folding operation, first we have to do shifting. Okay, then we have to do time folding. Okay, so here k is the variable. K is the variable, right? So what we are doing is we have to do n plus k first, next step. That is time shifting by n units. Okay, from h of n, what we have done? We have replaced n with k. H of k we have. Then we have to do n plus k. Based on this n plus k, we are shifting. Then we are doing n minus k, that is time folding operation. Then we fold the signal. The example, you can understand these steps, right? That's why, but you have to know these steps, right? First thing, we are renaming it x of n with x of k, h of n with x of k. Then we are time shifting by n units. Then we are doing time folding operation. And then what do we do? We got this, we got this. So we multiply x with h of n minus k. Then we will add for various n values. Okay. Now we will go into the second technique. Okay. The question is given as, what is the question given? X of n is given, h of n is given. What is asked? Output is asked. What method we are using? We are going for convolution operation. Okay, right. First step, replace x of n with x of k. So this is my x of k. So what is x of k? X of k is the same 2, minus 3, 6, 1. This is my x of k. Next, h of n is replaced, is changed to h of k. It's the same. Fine. Now, in moving train approach, what we do? Moving train and platform. Here, platform, if you go to a railway station, platform is going to be stationary. It is not at all moving. Only what is moving? The train is just the train. You can see the wheels here, right? Train is moving. Okay, fine. Now, what I'm going to do is this is the k values. These red values are the k values, and x of k. X I'm going to take as stationary. 2, -3, 6, and 1. We know what is x of k. 2, -3, 6, and 1. And here this -3 is the origin, 0. Okay, so what I am putting is at 0 it is -3, at 0 it is -3, at 1 it is 6, at time 2 it is 1. Similarly, at time -1 it is 2. Okay, this is the time value, discrete time values. Okay, that's your k value. Then, if n equal to -2, what happens to this expression? N equal to y of -2 is equal to x of k. Look at the right corner. Y of -2 is equal to summation x of k h of -2 minus k. So you have to find -2 minus k. Okay, so what I do to find -2 minus k, first I should do what are the operations available here? I have shifting operation, I have time folding operation. First I have to do shifting. Okay, so h of k is there. What is h of -2? It is delayed. Time delayed. You can look it here. Time delayed means what happens? 0 goes to 2. At time 1 goes to 3. Okay, so it is shifted towards the right by 2 units. Okay, so this is what is the value at the time 1? It is -2. Minus the time 1 goes to time 3. So this is 0, 0, 1, 2, and 3. Okay, right. Similarly, at -1 comes to +1. It is shifted to the right by 2 units. So h of k, first thing we are renaming x with x of k, h of n with h of k. Then we need h of -2 minus k. First what we do? We do shifting. Then we have to do time folding. Very important. You cannot change the order of operation, then get a wrong answer, right? First we do k -2 means it is delayed by time 2 time units. Okay, then minus k -2. This is, I will make a note here. This is time shifting. First step. Second step is time folding. See, this may look difficult, right? Once you look at the third method, tabulation method, it's will be very easier for you. Okay, but still you have to know, because in theory exams they will be straight away asking that use graphical technique to solve the convolution. There you cannot go for tabulation method, but for competitive exams and all, where we have only 1 minute to get the answer, right? For that you can go for tabulation method. Don't need to waste the time in the first technique and the second techniques. Okay, so first thing what I have done here is I have done the time shifting. Now I am going to fold. Fold means what happens? Positive time content will come to the negative time. Negative time content will come to the positive time. This is the time folding. So this is h of -2 minus k. That is h of -2 minus k. Right? So at 0 the value is 0. At 0 the value is 0. At 1 the value is 0. At -1 it is 1. At -2 it is 3. At -2 it is -1 -2. At -3 it is -2. Right? Okay, now look at what see, when the values are not there, we can put simply 0 there, right? So I have to multiply. No, so here 1 into 2 I can multiply, so the answer is 2. See, -3 into 0 0, this is 0. Here now no value, so we can take 0. 3 into 0 0, -2 into 0 0, 1 into 0 0. Okay, so it is only 2. So y of -2 is 2. It is same as the answer we obtained using the expression or the first technique. Now we'll put n equal to -1. Okay, n equal to -1, right? So what I need, I have to find n equal to minus 1 means go to the convolution expression. Yes, convolution, look at the right corner. I am putting n equal to minus 1. So y of minus 1 is equal to x of k, h of minus 1 minus k. Okay, so I have to find h of minus 1 minus k. I have to find h of minus 1 minus k. This is what I have to find. So what is the first step? The first step I have to find is time shifting h of k minus 1. What is h of k? H of k we know already. This is your h of k. Yes. Okay, fine. It's here. This is your h of k. What is h of k minus 1? It is shifted or delayed by minus 1 units. So what happens is it is 1, 3, minus 2. 3 will go to, it is shifted, so it will be like this. Okay, you compare, right? This is your h of k, this is h of k minus 1. It is delayed. Yes. 0 will go to 1. So at 0, what is the signal available in h of k? It is 3. Now it has gone to time 1. It is shifted. Okay. Next. So this operation is the time shifting operation. First we do time shift. Second, we go for time folding. Time folding. In time folding, that's h of minus k minus 1. So what I can do? Positive time will come to negative, negative will come to positive. So this 3 and minus 2, which is in positive time, will come to the negative time. So 3 minus 2, 1. So this is your h of minus k minus 1. Okay, that's what I mentioned here. At minus 2 it is minus 2, at minus 1 it is 3, at 0 it is 1. You can observe at 0 it is 1, at 1 it is 0, at time 2 it is 0. Now we multiply 2 into 3, 6, 1 into minus 3 it is minus 3. So you can add these two, 6 minus 3 it is 3. So the answer is 3. So y of minus 1 is 3. Okay. Now we can ask, sir, what is strain in platform approach? If you observe this closely, what is h of minus 2 minus k? It is this expression. Now what has happened is, it is shifted towards the right. This is shifted towards the right by 1 unit, right? Minus 3, 3, 1 has shifted to minus 3, 3, 1. You can see it is shifted. Okay, instead of minus 3, it is starting. See, this is starting at minus 3, the value is minus 2. Now the minus 2 is at what value? Minus 2 is at the time minus 2. It is shifted. Okay, that is why this is the platform, this is the train which is moving from left to right. Okay, now you can easily find 0 means h, x of k is there. Next n equal to 0 means 0 minus k. Okay, it is again shifted. Minus 2, 3 and 1. Now we can multiply 2 into minus 2, it's minus 4, minus 9, 6. Okay, now 1 minus k, it is again shifted. Compare this minus 2, 3. It is minus 2 is at the time minus 1. Now it is shifted to 0. Minus 2, 3 it is shifted. Now you can multiply. Remember, x of k is constant, right? For all the cases it is constant. Only h is moving. Each time unit, 1 unit it is moving. So multiply minus 2 into minus 3, it is 6 plus 18 plus 1. We get the answer 25. Okay, now n equal to 2, again it is shifted. Compare with the previous case, it is minus 2, 3, 1. Now it is minus 2, 3, 1, it is the time 0, 1, 2. Now it is moved to 1, 2, 3. Okay, now we multiply minus 12 plus 3 minus 9. Go to the last one, n equal to 3. Okay, so what is n equal to 4 means what happens? n equal, try it on your own. N equal to 4 means what happens? This will be again shifted. So minus 2 will be here, 3 and 1. So nothing is common. You cannot multiply. So answer is 0. Simple. Okay. This approach is called train and platform approach. And using this technique, I can go for even graphical. I will explain single case in graphical technique. It's also called graphical. We'll take the case n equal to 0. That will be very easy for us. Okay, fine. Okay. I'll take this case and explain using graphical. Graphical means this is 0, 1, minus 1, 2. At 0, the signal is minus 3. At 1, it is 6. At 2, it is 1. At minus 1, it is 2. So this is your x of k. Okay. Now, what is h of minus k? Okay, this is minus 2. It is 3. Okay, this is your x of k. This is your h of minus k. See, h of minus k. See, the numbers are there, right? I have marked in the graphical or a waveform, I can say. Okay, right. This is your x of k. This is your h of minus k. Now, what I need? I need y of 0. Yeah, I am explaining only for n equal to 0. Okay, this is your x of k. This is your x of k. This is your h of minus k. X of k, h of minus k. I have drawn it graphically. Now you have to multiply. At time minus 1, what is the value? 2. At time minus 1, what is the value? Minus 2. So I can multiply these two. 2 into 2. 2 into minus 2, it is minus 4. That is what I have mentioned here, minus 4. Then at time 0, it is minus 3. At time 0, it is plus 3. So minus 3 into 3, it is minus 9. At time 1, it is plus 6. Here at time 1, it is plus 1. So 6 into 1, 6. Here at time 2, it is 1. Here there is no signal time 2. So I make it as 0. So it is 0. So if you can add everything, I'll get the answer as minus 7. So I can output at 0 is minus 7. Or else I can say at 0, it is minus 7. Okay, this is the graphical approach. I have to take the input, I have to shift it, and I have to multiply each time instant, right? Instead of this, I gone for this tabulation, or I say this is the platform, this is the moving train. For each values, I am shifting towards the right one time unit. Okay, this approach is called train and platform approach, or else I can use say this as graphical approach. Okay, come to the third technique. This is the easiest technique called tabulation. Tabulation method. Okay, in tabulation method, what I do is I will take x in this axis, right? H here like this horizontally. I am going to multiply. Okay, just a multiplication. It is 1 into 2, 2, 2 into 3, 6, minus 4. Then next row, minus 3 into 1, minus 3 into 3, minus 3 into minus 2. Then 1 into 6, 3 into 6, 6 into minus 2, it is minus 12. Then 1 into 1, 1 into 3, 1 into minus 2. Okay, so just I am putting x vertically, h horizontally. I can change also because order is not important. Because what property? Commutative property. Now try to multiply. Okay, right? Multiplication and addition we have to do. So I take some different color. See what I am doing is I take the initial value, which is the corner. I will make a zigzag, right? I will make it like this. Then I will cover the next two values. Then diagonally, then diagonally, diagonally. This is how we have to make it, right? Now inside this region, I have to add. Okay, what is here? It is 2. It is 2 here. Here minus 3 into 6. I have to add minus 3 plus 6 is plus 3. Then 6 plus minus 9 plus minus 4. So it is minus 13 plus 6, it is minus 7 I have marked here. 1 plus 18 plus 6, it is 25. 3 minus 12, it is minus 9, it is minus 2. Okay, then sir, what is the, so this is the output. Wow, it's very simple now. Now, where will be the 0? What is the range of n values? Here again we have to use the common sense. What is the range of, what is the, where the y of 0 is, x of 0 is here. This is my x of 0 point. This is my h of 0 point, right? So this is my x of minus 1, this is h of minus 1. So minus 1, this should be y of minus 2. This should be, okay, get me. Similarly, come to the positive maximum value. Here, this is x of 0, x of 1, x of 2. Here, h of 0, h of 1. So here it is 2, here it is 1. So this is y of 2 plus 1 is 3. Okay, so this is I can fill the other values like y of minus 1, y of 0, y of 1, y of 2, which is the same answer we obtained using the first technique and train and platform second technique. Okay, so tabulation method is very simpler. Then there is another method to verify your answer whether it is correct or not. What does it mean is summation of the output is equal to summation of the input into summation of the impulse response. Okay, what is the summation of the input? Okay, what is summation of the input? What is the input here? 2 minus 3 plus 6 plus 1. What is the summation of the impulse response? 1 plus 3 minus 2. Okay, now you add everything. Add 2 minus 3 plus 6 plus 1. So it is 9 minus 3, it is 6. Yes, yes, 6. No, not, yeah, 6 only. Yeah. Then, similarly, if you add this, it is 4 minus 2. It is 4 minus 2, it is 2. So the answer is 12. What about the output? If I add the output, I will get the answer as 12. So you try to add 2 plus 3 is 5. 5 minus 7 is minus 2. Minus 2 plus 25 is minus 23. No, plus 23. Plus 23 minus 9. Plus 23 minus 9 is minus plus 14. Plus 14 minus 2. I get the answer 12. Okay, so you can add these all values, you'll get the answer as 12, and you add input and you add impulse response, then you multiply, it will be equal. This is the way to verify your answer whether it is correct or not. Okay, among the three techniques, I hope tabulation method is very easier, right? Only thing is you have to multiply and you have to find the lower limit and upper limit. This is very important, right? Okay, you cannot simply leave the answer like this. You have to mark which is your y of minus 2, which is your y of 3, and which is your y of 0. It's very important. Okay, then you have to be very clear how to make this zigzag. First value only 1, then 1 and this, I mean this diagonal value, then another 3 diagonal. Okay, if you make a table, you get the answer. Okay, for practice, I give you a problem. Okay, try this on your own. This is the input 1, 2, 3, 4. This is the impulse response 1, 0, 2, and 1. Okay, so this is your x of 0. This is your h of 0. So what will be the range of the output? What will be the range of the output? So this is your x of 0. This is your x of 0. This is minus 1. This is your 1. This is your x of 2. So this is your h of 0. This is your h of 1. So this should be h of minus 1. h of minus 2. This is for explanation I am writing, right? In the question only the numbers will be given and the arrow indication to indicate it whether it is which point is the zeroth sample will be given in the question. Only thing we have to understand this how to fill these values. Okay. Now what is the lowest most time limit? This is minus 1, this is minus 2. So the n range's lowest value is minus 3. 2. What is the higher topmost limit? It is plus 2. Here it is 1. So 2 plus 1, 3. So n is equal to minus 3 2 plus 3. Use any of the three method. Okay, any of the three method, but in theory exams they are asking for 10 mark or 16 mark question. Definitely we cannot go for tabulation method. Either you have to go for the expression or else go for the train or platform approach, or else you can make it as a graphical approach. It's up to you. But tabulation method is very easier, where you can get the answer within less than a minute. You can solve the answer. Okay, so I hope you should be getting this answer. Okay, for a moment I will show you the solution also. See, this is what I have done. Okay, I will just multiply. Okay, yeah, I can multiply, then I have made the zigzag. I got the answer. Okay, practice on your own, very important, right? I hope you learned something from this, useful from this video. Wish you a happy learning. Do subscribe the channel. Any doubts, please ask in the comment section. Happy to help you. Jai Hind.